Math 100 Lesson 8.2 is about graphs of functions. So the first thing I need you to know is that not every graph that we're going to see, not every graph that we are going to see is the graph of a function. Just because we see something on a graph doesn't mean it represents a function. So we're going to do some problems where I ask that exact question. Does the graph represent y as a function of x? Now, in order to answer that, before I put graphs up there for us to look at, we are going to use the vertical line test. Now, the vertical line test helps us decide if a graph is a function. That's its sole purpose. So here's what the vertical line test says. If a vertical line can be drawn on the graph, and touch the graph exactly once, it is a function. So if it touches it more than once, it is not going to be a function. Okay, so here are some graphs that we're going to look at. Our first graph that we're going to look at is going to be this one. All right, so the question is, does the graph represent y as a function of x? So I'm going to use a red line to represent a vertical line can be drawn. I just noticed over here where it says if a vertical, there should be the word line right here. If a vertical line can be drawn on the graph and touch the graph exactly once, it is a function. All right, so I want to draw my vertical line so that it at least touches it once somewhere. All right, so there's a vertical line. Okay, it touches the graph in exactly one point right there. Well, let's say I go to a different place. Let's say I move it over here. Still only touches it once. Now you only need to draw one vertical line, but I was just trying to show you that where you draw the vertical line is irrelevant. If you can draw it anywhere where it touches more than once, then it would be not a function. So this graph does represent a function. Right, let's see another one. Right, what if my curve looked like this? All right, so now we're going to draw a vertical line. I'm going to use red again. When I draw a vertical line, notice it touches twice. So that does not meet our criteria. So this is not a function. The vertical line touched twice. So this one is not a function. I mean, that's exactly how easy the vertical line test is to decide if a graph represents a function. All right, so that vertical line test, that's something we're going to have to remember. All right, so I'm going to draw you a graph, and we're going to answer some questions about the graph that I have drawn. Okay, so I've got a few points on the graph that I want to point out. So I'll put actual points here for us to see those. Alright, so here is our graph, and I'm going to ask a few questions. My first question is, what is the value of the function at -2? So what you have to remind yourself of is right here, this is saying that x is -2. And they want to know what is the y value that goes with that on the graph. Okay, so let's come over here to the graph where x is -2, and that's right there. And it's actually touching the graph right there. Well, what y value is it also touching? It's touching a y value of 0. So the function at -2 is 0. All right, let's look at the function at +2. Now remember, that means that x is +2. So we come over here to our graph and we find where x is positive 2. All right, positive 2 is right here, but I'm not actually touching the curve. So I have to look all the way up here. There it is. There's the point that I'm looking for. All right. So what is the y value right there? When x is 2, what is the y value? And in this case, it is 3. So the function at 2 is 3. We're just reading a graph. All right, what about the function at negative 1? So look over at the graph where x is negative 1 and find the y value that goes with it. So if I come over to where x is negative 1, x is negative 1 right here, but that's not on the graph. Okay, it's not on the curve, so I have to make my little self go all the way up here. There it is. So at negative 1, the y value is positive 2. All right, let's try one more. What about the value of the function at 0? When x is 0, the value of our function is, and in this case that would be negative 1. All right. And then last question using this graph, for what value of x is f of x equal to 3? Now we had a question like that in our table, but now we're looking at a graph. All right, so now they've given me this 3. That is not x. That means y is 3. So I have to come over to my graph, okay, to my y-axis is this one. So my y value of 3 is right here. Well, that's not on the graph. So if I slide my pencil over to here, that is the y value of 3 on the curve. So what x value goes with that is 2. The x value is 2 for that one. All right. So those are some graphs and functions. And now we need to review some things called interval notation and set builder notation. Both of these will give us the same information, they just look differently. My preference is interval notation, and most of our answers will be put in interval notation. However, my math lab is going to occasionally ask you for set builder. All right, so interval notation looks like this. Now I'm going to tell you what it means in words. Okay, in words, it means that the value of the variable, okay, the variable, and it might be x, it might be y, I don't know. The variable is greater than 1 and less than or equal to 6. All right, that's what parentheses 1, comma 6 bracket, that's what it means. The variable is greater than 1 and less than or equal to 6. Now, notice that I used the or equal to when I got over here to 6. That's because of the bracket. All right, the bracket says that it can equal 6. All right, notice I put the small number and then the large number 1 and then the 6. And since it doesn't equal 1, I had to use a parentheses. So in set builder, that same information would look like this. Let's say that the variable we're talking about is x, and then we put a little bar that we read such that. Okay, so x such that x is between 1 and 6, but it's equal to 6. And that's how I read that. X such that x such that x is between 1 and 6, but it is equal to 6. And so we use set builder for things like naming the domain and range of a function. Let's practice a couple more of those interval notations. right, if I have this one, bracket, -3, 1, bracket. So set builder would say, let's say we're just talking about x again, x such that x is between -3 and 1, and it is equal to both of them. Okay, because equal to is what the bracket indicates. All right, let's try 2 to infinity. All right, so x such that if it's from 2 to infinity, that means everything larger than 2, but notice I did not say equal to 2 because there's a parentheses touching the 2. Okay, right in front of the 2, there's a parentheses. If it had said 2 to infinity with a bracket, then that would say x such that x is greater than or equal to 2. All right, so the next thing that we're going to look at is some domain and range, so you can see how this actually applies to having to use it to do a problem. So let's see. Let me draw you a couple of graphs and we'll talk about domain and range. So I'm going to actually draw my graph in a different color just so it's very clear for you to see. Okay. All right, so here is a graph. It's got a funny looking little curve. And we are asked to just tell what are the domain and range. So let's remember that domain is our x values. Okay, that's not the answer here though. Range is our y values. Again, that is not the answer. Just trying to remind you what they are. All right, so when I look at domain, since those are x values and x and values move left and right, then I'm going to go as far as I can on the left of the blue curve. Okay, well when I do that, let me just use a color so you can see where I'm thinking. That puts me right here. Okay, that's as far as I can go to the left on the blue curve. Well, I want to know what is that x value. That x value is 0. So it is a closed circle, which means it is equal to 0. So I have to have a bracket 0. And then if I travel along to the right, okay, along this blue curve, if I travel along to the right, okay, then I'm going this direction, and that puts me at this x value. Well, that x value is 4. Okay, but when I look up there at the blue curve, there's an open circle, which means it is not equal to 4, so I have to use a parentheses. So this would be interval notation. Set builder notation would say domain is x such that x is between 0 and 4, and remember it was equal to 4. All right, now let's do y values. Okay, our range. So again, we think about range as y values, which is up and down. So I want to look at where is the bottom of the blue curve. Well, the bottom of the blue curve is that same point. Well, what is the y value right there? The y value right there is -1, and it is equal to -1, so I put a bracket. Now I follow along the curve, okay, moving upward, okay, along the curve, and I find a y value of also 4 in this case. but it is not equal to 4. Okay, so set builder, this time these are y values, so I have to use the letter y, such that y is between -1 and 4. Notice I put an equal to beside the -1. So that domain and range will just take some practicing. There will be some of that in your homework. If you have any questions about that, please let me know. Have a great day.